students, welcome to our science program. At the beginning, don't forget to follow our channel on the YouTube. Okay, last time we started talking about lenses and we knew the difference between convex lens and concave lens and the main concepts of the lenses and the formation of image by convex lens. Today we will start talking about formation of image by concave lens and vision defects, which are long-sightedness and short-sightedness. So let's start part 2 of lesson 2, unit 2. Unit 2, lesson 2, lenses. Okay, the image that is formed by concave lens. Last time we started talking about formation of image by convex lens, but today we will have concave lens. We had many cases in convex lens, but in the case of concave lens, we have just one case. In this case, object is placed at distance more than the focus, any distance more than the focus. And now we are trying to draw the image. Okay, to draw the image, we must draw two light rays. One of them is parallel to principal axis, and the other one is passing through optical center. Okay, we knew that light ray that passing through optical center, it passes without refraction, as normal. But light ray that falls parallel to principal axis, it wants to diverge, but diverge by extension of virtual focus. So the diverging ray is coming from extension of virtual focus. Here we have the intersection of the two rays, and this is the image. The image here is virtual, small in size, and erect or upright. Of course, it's virtual because it's formed by intersection of extension of rays and smaller in size than the object and upright image. Okay, give reason for. The concave lens is known as diverging lens. Again, concave lens is known as diverging lens. Try to think. Perfect. Of course, because it diverges light rays after they pass through it. Concave lens diverges light rays, and so it's called diverging lens. Okay, another one. Give reason for. The image that is formed by concave lens is virtual. Here virtual means not real. Why? Try to think. Excellent. Of course, because it can't be received on a screen. We can't receive image that is formed by concave lens on a screen because it's formed by intersection of refracted rays extension. So the image that is drawn by extension of refracted rays is called virtual image and can't be formed on screen. Okay, let's talk about the vision. Okay, to understand vision, light rays reflect from the body to fall on the eye, of course, to see the object. Okay, here we have an image that representing the structure of the eye. Of course, the eye is like sphere or a ball. Okay, and inside the eye or at the back of the eye, this is the retina or the screen of the eye. At the front of the eye, this is the cornea. It's the first part of the eye, and after it we have a lens or convex lens. By the way, this lens is not made of glass or plastic. It's made of some kind of protein. So our eye is like ball or a sphere. The outer part is the cornea, and after it the lens is of course convex lens, and at the back of the eye the retina or the screen of the eye. Okay, here we have an object in front of the eye. Light rays enter inside the eye and refracted by the lens and forming image on the retina. Of course, we can see here the image is inverted or upside down and smaller in size. So how can we see upright objects? Let's see. Light rays refract when passing through cornea, then the lens. So the first refraction of the light starts at cornea and after it on the lens, convex lens. The refracted rays are collected on the retina, forming small, real, inverted image. Of course, it's real because it can be formed on a screen. But the problem now, it's small image and inverted image. So the question is, how can we see the objects upright? Okay, at the end of the eye, there is a nerve called optic nerve. Optic nerve sends the image to the brain, and the brain recorrect the image and become erect or upright again and its normal size. So again, image is formed inside the eye, inverted, real, and small in size, but the brain correct it again. Notebook. The diameter of the eyeball. What is the diameter of eyeball? Is the distance between optical center of the lens that plays in the front of the eye and the retina. So diameter of the eye determined by distance between optical center of the eye lens and the retina. Of course, retina is the screen of the eye. To see clearly, the image must be formed on the retina. So, to see the image clearly, image must be formed on the retina, not before it or after it. Okay, the person with normal vision or normal vision person can see clearly far objects clearly at distance 6 meters. So, the far object according to normal eye is present at 6 meters. This is for normal vision person. This clear vision remains if the object comes closer, not less than 25 centimeters. So, normal vision person can see clearly between 25 centimeters and 6 meters. Okay, vision defects. Short-sightedness and long-sightedness, or we can say short sight and long sight. Okay, let's compare between them. First, short-sightedness. In short-sightedness, the person can see near objects clearly. Any near object, it can be seen clearly, but far objects seem distorted. Distorted means not clear. So, in the case of short-sightedness, the person can see near objects clearly. Short-sightedness, near objects clearly, but far objects not clear or distorted. So, the opposite in long-sightedness. The person here can see far objects clearly and can't see near objects. Near objects in this case will be distorted or not clear. So again, short-sightedness, see near objects clearly. Long-sightedness, see far objects clearly. Okay, let's talk about the position of the image. In the case of short-sightedness, image is formed in front of retina. When person, which has short-sightedness, look at far object, image of far object is formed in front of the retina. And to see the image clearly, it must be formed on the retina. But In this case, image is formed in front of retina. It's called vision defect. Opposite in long-sightedness. Here the image of near object is formed behind the retina. Formed behind the retina. And of course, you know that to see the image clearly, it must be formed on the retina, not in front or behind. So, short-sightedness image is formed in front of retina, and in long-sightedness image is formed behind the retina. Okay, of course, in these two cases, image will not be clear. So, what is the reason of short-sightedness? Okay, first reason, the diameter of the eyeball is too long. Diameter of eyeball is the distance between optical center of the lens and retina. In this case, diameter of the eyeball is too long, so image can't reach to retina. Okay, opposite in long-sightedness. First reason, diameter of eyeball is too short, so image is formed behind the retina. Long distance more than the retina. Another reason, the eye lens is more convex. When the eye lens is more convex, it has very short focal length, so image is formed at distance less than diameter of the eye or in front of retina. But the opposite in long-sightedness, the eye lens is less convex or thin, so it has very long focal length. So the image is formed behind the retina. So again, the two reasons of short-sightedness, diameter of eye ball is long and lens or eye lens is more convex with a short focal length. In this case, diameter of eye is very short and eye lens is less convex or thin, so it has long focal length. So image is formed behind the retina. Of course, here decreasing focal length in the case of shorted sight and increasing focal length in the case of long-sightedness. Okay, what about the correction of these two cases? Correction of short-sightedness. Of course, by using eyeglasses contain concave lens or diverging lens. Why concave lens or converging lens? Here, light rays are coming from the object and refracted or diverging by the concave lens. So, image is formed on the retina instead of in front of it. So, correction of short-sightedness by concave lens. In the case of long-sightedness, we use convex lens. Why convex lens? Because convex lens collect or converge light rays. So, in this case, image is formed on the retina instead of behind it. So again, let's make quick revision. We have two cases in vision defects, short-sightedness and long-sightedness. Short-sightedness, the person can see near objects clearly, but far objects not clear. In long-sightedness, the person can see far objects clearly, but near objects not clear or distorted. Reason of short-sightedness: increasing the diameter of the eyeball or elongation of eyeball, and the eye lens is more convex with a very short focal length. In this case of long-sightedness, diameter of eyeball is short and the eye lens is less convex with a large focal length. Image in short-sightedness is formed in front of retina, Image in long-sightedness is formed behind the retina. So, the most important point, how to correct short-sightedness and long-sightedness. Short-sightedness is corrected by, yes, concave lens to diverge light rays and form image on the retina. And in the case of long-sightedness, we use convex lens. Why? Because it converge or collect light rays and form image exactly on the retina. To be clear, of course. Contact lenses. If you want to not use eyeglasses, we can use contact lenses. Okay. Contact lenses are used instead of glasses. Why? Of course, to treat or correct vision defects, which are short-sightedness and long-sightedness. Okay. Contact lens, very thin lens and made of plastic, and can stick to the eye cornea by the eye fluid, of course, to correct vision defects. Cataract disease. Okay. This is due to some reasons. Of course, you know that eye lens must be transparent. Why? To allow light to pass through it and form image on the retina. But in some cases, this lens become dark, so light can't pass through it. So here we have a disease called cataract or darkness of eye lens. Okay, what are the reasons of cataract or darkness of eye lens? First, old age. Old age causing cataract. Illness. Illness or increasing temperature of the body may affect the structure of eye lens and become dark. So, in the case of illness, we must decrease the temperature of the body. Side effects of drugs. Okay, drugs here means medicines. Medicines are taken under medical description. Okay, if we take medicines under medical description, we will reduce the side effects of drugs or medicines. But taking medicines without medical description causing many side effects. One of them is cataract or darkness of eye lens. That means the lens of the eye become dark and can't allow light to pass through it and form image on the retina. Last reason is genetic redness or genetic reasons. Okay. Here we can see image of the eye. This is the cornea and this is the eye iris. It's the colored part of the eye. It may be brown or green or blue. This part controls the size of this opening. This opening is called eye pupil, through which light is passing inside the eye. Okay, we can see here clearly the lens inside the eye or eye lens. Here it's not clear or transparent. It starts to get dark. So here we have cataract disease or darkness of eye lens. Okay, what are symptoms of this disease? Let's see. The lens becomes dark. The eye lens becomes dark. Here we can see eye pupil of the eye is get wider to allow more light to pass inside the eye. But here we have dark lens. It can't allow light to pass inside it. Okay, what about the treatment of this case? Of course, it can be treated by surgery, only by surgery, to exchange the eye lens by another one that made of plastic. So, we can treat cataract disease by using, yes, another lens made of plastic instead of the normal eye lens, so the person can see again. Dear students, now we will have quick revision about the formation of image by convex lens. Let's see. The cases of the formation of image by convex lens or collective lens. Okay, let's make our revision. Okay, in the first case, if light rays are coming from very far source of light, as we mentioned before, perfect, like the sun. Light rays of the sun are parallel, so parallel rays are collected or refracted in one point, which is perfect, the focus. So here in the first case, the position of the object is very far like the sun. Sun rays are parallel and fall on the lens. Okay, what will happen? Here the position of the image. Image is formed at the focus. Image of the sun is formed at the focus. And of course, it's real image. Real image here means, yes, of course, can be formed on a screen and very tiny or very small or dot. Of course, as we said before, we can use this phenomena in burning piece of paper by collecting light rays and concentrating it using convex lens. Okay, what about the second case? Try to remember. Yes, of course. Here we have the object at distance more than radius of curvature. More than radius or curvature or greater than double focal length. We draw two rays. One of them is parallel to principal axis and the other is passing through optical center. Okay, try to conclude. How can we draw the image? Yes, of course, light ray that falls parallel to principal axis, it refracts in focus. And light ray that is passing through optical center, it passing without refraction. So, at the point of intersection of these two rays, we will draw the image. Okay, so the position of object is at distance greater than radius of curvature. Okay, what about the position of the image? Okay, you can see clearly here the position of the image is between center of curvature and focus, or at distance more than focal length and less than center of curvature. The properties of the image, it will be real image, that means can be formed on a screen, and inverted, upside down, undimensioned or smaller in size than the object. Next case, we will put the object at the center of curvature, and now we want to draw the image. Of course, you knew that we will draw two light rays. Why? To get intersection and form image. So, light ray that falls parallel refracts in focus, and light ray that falls in optical center, it passes without refraction. So, at the point of intersection of these two rays, we have the image. Here, the object at the center of curvature, the position of object at center of curvature, and of course, the position of the image is also at center of curvature. Okay, what about the properties of the image? It will be real, inverted, and equal in size to the object. Okay, let's try to remember the next case. Yes, of course, here the object is between center of curvature and focus. We draw two light rays, one is parallel, the other passing through optical center. At the point of intersection of these two rays, we have the image. So, position of object between center and focus. What about position of the image? Yes, of course, at distance more than radius of curvature or more than double focal length. the properties of the image, it will be real, inverted, and larger in size. Okay, try to remember, when you put object at the focus, light rays in this case will be refracted parallel to each other. So, when light rays are parallel to each other, here is the position of the object at focus. And what about the position of the image? Try to conclude. Yes, there is no image is formed because light rays are parallel. But in the last case, here the object at distance less than focal length, we try to draw the image. Light ray that falls parallel, refract in focus, in optical center passing without refraction. So, by drawing the extension of refracted rays, here we have the image. So, position of object, of course, less than focal length, and position of the image in front of the lens at the same side of the object, not in the other side. But last thing, the properties of formed image, it will be virtual because it's formed by extension of refracted rays, upright and magnified, bigger than the object. Dear students, at the end of our lesson, don't forget the main concepts of the concave lens and the formation of image by concave lens, and the main difference between long-sightedness and short-sightedness and how we can correct them. Thank you very much, and till we meet again, goodbye.